Now in the last video we saw how to predict the charges that ions, common ions of elements should have. And one of the things that we looked at was noble gases, like neon here that I'm pointing to, have got especially stable configurations. We know that because they don't form compounds with other elements. And other elements, if other elements can get that configuration, they will be especially stable too. For example, fluorine can pick up an electron and attain a neon configuration. If it picks up an electron, it's going to be an F-, and F- will have then the neon configuration. We said oxide can pick up 1, 2 electrons to give it a -2 charge and get a neon configuration. Now, what we didn't say is that that works on the other end of the table too, in the S block. If we have sodium, it can get a neon configuration by giving up an electron. So if it loses an electron, it'll have a positive charge and it will have a neon configuration. What about magnesium? It needs to lose 1, 2 electrons to get to neon. So magnesium forms +2 ions. Now it has a neon configuration. So there's a whole series of things that have got a neon configuration here. What about aluminum? Aluminum needs to lose 1, 2, 3 electrons to get to neon. That's neon. What else? Well, did we miss anything over on the fluoride and oxide side? There's nitrogen. Nitrogen can gain 1, 2, 3. If it gains electrons, it's going to have a negative charge. And now it'll have a neon configuration. So all of these, including the atom neon, have a neon configuration. And we call this an isoelectronic series. Isoelectronic because they all have the same electron configuration. This is an especially stable configuration. So note a couple things here too. The things with negative charges are always nonmetals. The things with positive charges are always metals. Metals tend to lose electrons easily, and nonmetals tend to gain electrons easily. So here we have an isoelectronic series that all has the same configuration. And we can rationalize why elements react in reactions now according to whether or not they're trying to gain or lose electrons. For example, let's see if we can understand this reaction. Sodium metal comes together with chlorine gas to make sodium chloride, which is completely unlike the two things it started from. This is a soft silvery metal, extremely reactive and deadly poisonous. Here's another deadly poison, chlorine gas. Will do horrible things if you breathe it. But table salt, NaCl, doesn't look the same, is not toxic, not in small quantities anyway. So what's happening here? Why do these two come together to make that? Well, what's happening is the sodium wants to get a neon configuration. And the chlorine, a chlorine atom wants to get what? Let's look at where chlorine is. Chlorine wants to get an argon. Chlorine wants to get an argon configuration. So this is going to eventually become Cl minus. Now we can put 2's in front of these things, because there's 2 of them you're going to get. So there's an electron transfer that occurs. The sodium gives its extra electrons, electrons that it does not want, to the chlorine. It becomes Cl minus. And then those go together and they form sodium chloride, which you can kind of picture as a sodium ion stuck to a chloride ion. And you're making 2 of those. And in fact, you don't get 2 molecules like this. You get just a lot of sodium ions and chloride ions packed together. We'll talk about this in the next lesson. But that's essentially what's going on here. So the electron configurations have led us to an understanding about how ions form and why they have the charges that they do. And that's important because we get reactions then. These ions, being positive and negative, can stick together and form ionic compounds, we're going to call these things. So in the question below, I'm having you pick out some isoelectronic series on the periodic table and list the ions and the atoms that are inside the isoelectronic series. We're going to use this again a little bit later.